So the volume of pyramids and cones. So once again, let's remember what volume is. Volume is the amount of space inside a three-dimensional solid. So if you wanted to fill this object with water, how much water would it take? The volume in a pyramid or cone is a third of the volume of the corresponding prism or cylinder. So so I'm saying that this is a triangular prism, here's a triangular pyramid, and if you take this, divide it by 3 or multiply by 1/3, you'll get the volume of this. And the reason for that is because if you take one way to visualize this is imagine splitting a cube into 6 congruent square pyramids. It might be hard to see these 6 congruent square pyramids, so I've animated this for you so you can see. Those are the 6 square pyramids. They're separating so that you can see that there are 6 of them. They're all the same. So you have 6 congruent square pyramids, and then if you put them together, they make a cube. So we take this cube, split it into 6 congruent square pyramids. So 1/6 of the cube will be the square pyramid. Now imagine slicing this cube in half, right there. Slice the cube in half there through the center, so that you just have what's above or what's below the half. So now you get something like this. We've cut the cube in half, so now really it's just 1/3 of this this rectangular prism is the rectangular square pyramid. So this is what we're saying, that we can take the prism, multiply by 1/3 to get the pyramid. Take the prism, multiply by 1/3 to get the pyramid. So here were all of our prism and cylinder formulas: base times height, length times width times height, 1/2, length times width times height, pi r squared times height. So because of this rule, we can take each of these and multiply by 1/3. So this will be, you'll see a third, a third, a third, and a third appearing right next to whatever the formula was. So 1/3, 1/3, 1/6. Why is that 1/6? Well, 1/2 times 1/3 is 1/6, and then this is 1/3. Sorry, make sure that you have these formulas. So, find the volume of this cone. So volume is 1/3 pi r squared times height. 1/3 pi 4 is the radius, and the height was 8. So now we can do, multiply those together, get 128 pi. If you don't like that, you can say that it's going to be approximately 134 cubic miles. I'll accept either version. Here, the volume of a pyramid is 1/3 the area of the base. In this case, it's length times width times the height. So the length was 1, the width was 1, the height was 1. So multiplying all that together, we get 1/3 cubic feet. Yay! Now you see the base is a right triangle. We have 1/6 length times width times height. This is because 1/3 times 1/2 gives us 1/6. So length was 6. The width is 8, and the height has to be perpendicular up to the apex, is the 10. When you multiply that together, you get 80 cubic kilometers. Please note that oblique or slanted solids have the same volume formulas. Again, this is by Cavalari's principle, so you could still use 1/3 pi r squared h to find the volume of a cone. So pi 12.2 squared times 25. 25 times 12.2 squared times pi times 1/3. I'm getting that this is about 3,897 cubic feet. All right, that is how we find volume of pyramids and cones.